Really? You're welcome. Are you actually?
I should get a double standard. Do you want to play me?
Not really. I mean, over here, I don't want to. It's so.
He's got lots to talk about, so I'm just going to go ahead and let him get started.
Thank you. I wish I got paid by the pound because this is like the biggest crowd I've ever seen in here. We weighed you all and gave me $1 for every pound. Just kidding. So I guess the reason people are here is maybe because it was really warm in December. I'm gonna guess. But we'll talk a little about this potential major East Coast winter storm. And as for here in points, in central Pennsylvania, I guess it looked good on paper at least a few days ago. So we'll talk a little bit about the December to remember. Most people will remember the December from 2015 for the record warm. And of course, if you've been reading the newspaper articles, we'll just do a quick review of how warm it was in December. But the whole year, 2015 was the warmest year since we've been keeping records and the disputes of what years those are. Every different data set shows that it's the warmest year for the data we have for different data sets and different time lengths. Then we'll talk about our pending storm and the potential record event. Unfortunately, there won't be any records set here unless somebody brings a bunch of albums and sets them on a table. But the best impact looks to be to our south. We'll look briefly at this storm and some other storms in history and how they affect the DC area in here. We'll look a little bit at the ensemble forecast systems and kind of the disagreement between the GEFS and the SREF, which is a point of interest and frustration if you're trying to forecast this. And then we'll talk about the weather for the next few days, and I'm sure a few of you will voice your opinions. So December 2015 was the warmest month here locally, but it was the warmest year ever globally by a large measure of data sets. NOAA's data sets, NASA's data sets. There were a couple other data sets I mentioned. It's been in the newspapers, I guess, over the last 2 or 3 days now. If you've been reading them, I just read the New York Times article on it this morning. But December 5th, 2015 was we regionally crushed the old record warmth in most locations by a minimum of 3 degrees Fahrenheit. That's not the record. That's the previous record all-time warm December. We were most places around here and up through New England and down through the Mid-Atlantic region were generally 3 to 8 degrees warmer than the previously all-time record warm December. That's unprecedented. It was really warm, of course, in the Christmas period. I took a nice, it was a 30-mile bike ride on Christmas Eve. I would have gone on Christmas Day, but I was advised not to leave the house on a bike on Christmas Day. So anyway, so the month was unique in that I went back and looked through record warm Decembers. It had 2 unique warm surges. Most of the previously record warm Decembers usually were front-loaded or back-loaded or had a warm spell in the middle. They couldn't get 2 record events in the same month. So that really helped us here. And this led to plenty of record high max temperatures and record high min temperatures, and of course a couple of severe weather events focused right around a couple days either side of Christmas, and we'll get into those. So it truly was a December to remember. And so this is of the 121 years that they use at NCDC, it ranked 121. It was the warmest of the warm. And if you move to the eastern United States, basically from about the Mississippi River, give or take a state, it was the warmest on record in the whole eastern United States. And everybody thought how cold it was in the west, but if you look at those numbers, none of them were really that cold. California, and Arizona maybe were on the cold end if you look at it, but most of them were pretty close to normal actually. If you look at those numbers, 57 out of 121. So anyway, this is the number of high temperature records that was set in December of 2015. You can see clearly there was a peak around the 13th these are records and tide records and then overall records. And then you can see there was a peak that focused around Christmas. It was these are the number of daily records that was set, and it was just quite impressive, right? And then if we go to the record high minimum temperatures, you see the same effect. And one of the things that kept the record high minimum so high is it got really moist. So our overnight lows, we had dew points, in the upper 50s in December. So that really kept the temperatures really high, and made it very dewy on Christmas Eve to ride a bicycle, by the way. So, but you can see we had 2 clear and distinct warm episodes, which apparently of this nature in December are hard to get, it turns out. So this is what the late month warmth looked like. This is we have the 500 heights and anomalies. And in this panel we have 850 temperatures. We have the surface pressure, and we have the precipitable water. You can see it was very warm and moist. It kept the high temperatures, low temperatures up at night. We had an incredible closed 580 meter contour for the heights, huge Bermuda high in December. And you can see that at the surface there was a huge Bermuda high. And we had low pressure over the southwestern United States. There was a trough with below normal heights out in the west, and of course we heard about some of the rains and rain issues they had out there, and eventually they had the blizzard that killed all the cows after Christmas. But we were just unbelievably warm in the eastern United States. You know, you would associate this kind of a pattern with the Bermuda high like this more like, say, for July than you would in December. So, and this was the kind of focus period right around Christmas. And there was actually a closed 594 contour just off the east coast. Unbelievably, like the whole this period of time, the heights were averaging 2 to 3 standard deviations above normal, and it was extremely moist. And you can see probably down here in the lower panel why we had the severe weather outbreak and the heavy rains in the southern United States, and why anybody went to the AMS meeting got to see that the Mississippi River was peaking just a few feet below the levees. It was pretty impressive to look out the window and say, well, that river's pretty high. And, but an amazing Bermuda high for the month of December. And then they just show, this just shows like Philadelphia State College, Harrisburg, a few other locations, and it shows what the warmest year was on record for the December, and then it shows what the average temperature was for the month. And you can see there's a few outliers, like Pittsburgh, 1889 came in the big winter, but usually it's 2015 pretty much took the first slot. It's interesting that we saw a couple years in these different data sets. Like if you look at Philadelphia, you see 1923. 1923 showed up in Harrisburg, and it showed up in a few other locations, and like State College, it was one of the warmest years. So we went back in the reanalysis, the 20th century reanalysis, and kind of compared them. This would be a nice little paper for somebody to write. I just did this for fun before Christmas, and sorry, after Christmas. But you can see there were a lot of really warm years in between the 20th century and the CFS. Was to go back and look at them, you can see how the patterns compared. And that's why I realized it was really hard to find a month where you got 2 really warm episodes, which made December 2015 so distinct. So this is the 20th century reanalysis. You can take it or leave it. It's reconstructed from pressure and data and stuff. But you can see this is what the pattern looked like for the month of December of 1889, if you believe this. And it was kind of warmer in the central United States, but it was quite warm. But it looked nothing like 2015. I did 1923 and 2006, and none of them looked like this. And I picked regions of the month to try to hone in on the details. And just we lived in a unique month. But I think the 20th century analysis data has some limitations on how they do the data. So 1923 and 1889, like maybe the temperatures had a different exposure back then because the patterns don't look that great. And yet these were the 2 previous record months. So it was kind of odd. So it was an interesting period of time, and we all had a warm feeling about December. So now we'll change gears unless anybody has any questions about December 2000. So everybody's chomping at the bit. Everybody's a snow crow, recruiting their feathers. Right? So we're looking at this potential, clearly historic storm that of 22, 24 December, January, right, 2016. So the question, will the storm be significant? In all high likelihood, it will be. We'll talk about some reasons why we believe that to be true based on the QPF and the anomalies in things like the winds and the pressure field. And where you ask, that's a good question. But clearly it looks like it's going to be the mid-Atlantic region. Clearly it looks like the real heavy or snow, though they may be mixed with sleet, there are precipitation type issues, probably be focused south of Philadelphia. It looks like right now Washington, D.C., Baltimore, maybe even Richmond are in the corridor for the best QPF, if you will. I'm not going to say exactly snow. And for the best, highest winds. We'll look at that briefly. There are a lot of forecast issues. There were issues between the models and the ensemble forecast systems. Initially, up until about a day ago, there was a big discrepancy. The European Center and its ensemble was further south and east than the GEFS and the GFS ensemble system. And then this REF came in the last 2 days, and it's like, holy crow! It's like further to the north and west of all the other systems. If you believe the EC and the GEFS, and if you're making a super ensemble with those, you're probably not too worried about snow here in State College. I suggested to my wife we drive south and find a bed and breakfast and bring both sets of skis so we can go downhill and cross country. But because it'd be better south of here. But anyway, right now the big issue is between the GEFS and the SREF. And this storm looked good on paper a few days ago, and people were really getting excited about big snow in central Pennsylvania. And a lot of weather yahoos on Facebook and blog space were talking about these huge snow amounts. And even as late as last night, some of them still had incredible numbers across Pennsylvania. And then some people posted some really high numbers. But it looked really potentially good here in State College. And then the GEFS and backed off. The EC never had the big snow potential here. But the SREF, love it or list it, so to speak, thinks it's going to snow big here. So this is one of the reasons we think it will be a big storm. This is this was the most recent version of the GEFS, and the upper panels show the 850 winds and the wind anomalies. And you can see the green zone is for spinach. No, the green zone is showing is the 6 sigma U wind anomalies, -6 sigma U wind anomalies. And years ago, we did studies with Paul Knight and some of his students. We wrote some papers that we got in some journals. And usually when you see -3, -4 sigma, you have a really meteorologically significant East Coast winter storm. When you see 6 sigma, that last time I saw 6 sigma winds like this, it was October 2012. It was a little storm that came up the coast around Halloween. I forget the name, but so these 6 sigma winds, Sandy aside, they're not very common. So we know that based on the structures being produced, and this is 21 members producing these. If you look at the GFS, you'll see a stronger signal, of course, because it's only one model. This is a blend of 21 models, and we're getting this high signal. So we have to have a convergence of solutions to get such a high signal. But when we see 6 sigma winds in the models, we know we're going to have probably a big coastal erosion, strong winds in some locations, and we're going to have a pretty good QPF event, although the QPF of the models knows where the QPF is going to fall, so it'll probably have a better gauge of that than just looking at the patterns. But we know this is going to be a significant storm because of a lot of these details, and I think the U wind anomalies kind of like sealed the deal. And we've been looking at these now for 3 days. We knew this was going to be a historic storm, but the details haven't quite settled yet, so to speak. Neither has the snow. So here's an example of the emergent forecast from the GEFS, and I just picked the most recent cycles. From 60 this morning, worked my way backwards, and this shows this is the probability. This is actually the 25 millimeter contour, and the shading shows the mean of all 21 members, and the thick black line is the ensemble mean location of the 25 millimeter contour. The black dot is State College, where all the snow crows live, and at least in this area, and the individual colored contours show each member's 25 millimeter contour. And you can see the forecasts from the 19th. This is early the 19th. This is 12Z the 19th. I skipped the 18 and 6Z runs here. And this is the 0Z the 20th. And then finally we're here. This is this morning's run. And you can see we're literally at the edge of it all. But there's a heck of a tight gradient between here and Harrisburg. But you can see over time the precipitation shield, at least the northern edge, has shifted further and further south and east. I'm sure if you look at some of the plume diagrams you saw a couple days ago, there were some forecast members, a few outliers in the GFS that implied we'd have 3 inches of QPF and it was all going to fall as snow. So people getting excited. You figure 12.5, 13 to 1 ratios around this time of year, you'd be really excited about 3 feet of snow, but that ain't going to happen. But if you look, you can see there's a closed 50 contour that's been focused south and or over the Maryland, Virginia area, the Delmarva, and a lot of that at least on the west side of the Chesapeake will probably be mainly snow, maybe some sleet. So you can see it's been holding steady for at least this area, the Mid-Atlantic. If you can see the mouse on the screen, that's going to be a really big QPF event. And we're literally on the edge, and I don't mean the shaving cream. So anyway, this is the probability of 25 millimeters of QPF, and you can see we've moved out of the 25 millimeter QPF zone by just a hair. I mean, we're in the 5 to 10% range, but the 30% range is not too far to our south. So we're really literally on this really sharp edge. So if you're forecasting for State College, it's difficult. Even if you're forecasting, I believe, for the lower Susquehanna Valley, it's been difficult because there has been this progressive slide to the south and east. But whenever there's a high pressure system in the NSET models, I don't know why this is true, but it always works out, and there's a low coming up the coast, the low usually kind of tracks a little bit further south and east than earlier forecast. If there's no high, it always goes to the west, of course. But this, you can see that we're literally on the edge of the 1 inch potential QPF. And then if we go to 50 millimeters, it's even a low probability in the lower Susquehanna Valley, but it stays focused, and there's there's this mesoscale band, if you will, of maximum focused over the DC area. So you'd be optimistic if it was all snow, you'd probably say 12 to 1 ratios down there. They're looking at a good potential 2-foot snowstorm. And then if we get really crazy, we put the 75 millimeter probability down there. So we're looking at 3 inches. The models still have some hope that you can't rule out a historic snow event. And with those easterly winds and then the QPF we're looking at, you're talking a place that gets 18 inches of snow a year, and they're looking at the models are suggesting they can get between say 20 and 36 inches of snow. You get a whole season's of snow in 24 hours. That's meteorologically and climatologically significant. So it's going to be a real interesting event, but most of the interesting stuff will probably not be in State College. This is the SREF, and to do the SREF with this new software, I have to do a lot of finagling. It took me an hour to do this, but the SREF is much wetter. So you can see the most recent SREF, we're like in the meat. Like we're sitting at 25 millimeters in the SREF. We'd probably be 13 to 1. You'd be looking at a 13-inch snowfall here. So you can't rule that out. But if you look at the GEFS, we're just a little bit further north. And this could be a lot of issues too, because if you're looking at the data on its native grid, or on a quarter-degree grid or a 1-degree grid, you're going to get a different solution here. So not only do we have a tight gradient, it's how you get if the model isn't on its native grid, you could be looking at interpolation issues here. So it's going to be really dicey here. So if you're a fan of the SREF, raise your hands if you're a fan of the SREF. I mean, everybody who likes snow should raise their hand. But if you're a fan of the SREF, we're looking at a 8 to 12 inch snowstorm probably in State College. If you're a fan of the GEFS, we're looking at maybe 1 to 2 inches of snow. So it's really tough. But one thing's consistent there. The SREF has at least 50 millimeters. If you look, it's hidden in the spaghetti. It's lunchtime, of course. But hidden in the spaghetti down here in the DC area, there's actually some 60, 70 millimeter contours in the DC area. So, and most of it will be snow, but there are precipitation type issues here. So this is 9 cycles of the GEFS. I kind of reversed this. My eyesight is not very good. The most recent forecast is up here, and these are all valid at 60 on Saturday. It was 60 on Saturday. So just after midnight here, and they can see they're pretty consistent with the storm somewhere off the Carolina coast. And you can see they all have the big high to the north, which kind of favors the storms, not going to the north and the northwest. I didn't look at the Pocatello Ridge rule, and then this is the forecast for the same 9 forecast cycles, showing the storm as it moves off Cape Hatteras. I've heard people say we don't get Hatteras lows anymore. We got one. At least we got one in the forecast system. And we're looking at a 3 to 4 sigma cyclone. So it's a pretty deep cyclone, and you can see there's been, for the naked eye, it's fairly consistent. Maybe some of the forecasts, if you go back to the forecast here from the 18th, the low look maybe was a little further north, but it wasn't as deep because of the uncertainty. The spread would show that too. When I was looking at the storm evolve, like over the weekend, you can see there was a lot of spread on the north and west side of the storm, suggesting intensity and placement issues. And a lot of that spread's going away. But in order to get these really big anomalies, you have to have a convergence of solutions. I don't think this storm's taken an ideal track for us, but there is a heck of an easterly gradient implied if I can find the mouse. If you keep losing the mouse, you need a cat. So you can see the really tight gradient between the high and the low, so the easterly flow is pretty good. And this is the QPF shield, and you'll notice the QPF shield, as the models converge, this is the ensemble mean, has the northern edge has gotten sharper and sharper and sharper with time. And we're just south of that edge. And this is a half-degree data, so quarter degree, pick your grid point. Could be some issues here, but generally speaking, the QPF shield the northern edge is really sharpened up, and there's a lot less precipitation over places like northern Ohio, northern Pennsylvania, and in these more recent forecasts. They really can see how the northern edge is really cleaned up versus these older forecasts down here. So the older forecasts with a lot of spread got everybody excited. So a couple of GEFS points, a similar cyclone track in previous forecasts, strong low-level jet. We saw the 6 sigma jet in the mid-Atlantic region, which kind of gets you excited. It's trended the QPF and the storm a little bit south. Definitely you can see the northern edge of the QPF shield. That was true. It was slower to pull the QPF shield in the cyclone track further south and east relative to the EC. It lagged by almost a day. So but now the EC and the GFS and GFS are very kind of internally consistent. I don't have any EC products to show. So I was in a dialogue at the map discussion list, and Henry Margansetti sent me this. I'm sure some of you got this. He just said, if you're going to get a foot of snow at DC, climatologically, it snows. When you have a big snowstorm in the DC area, you get snows in State College. You notice these are the storms, and they found every storm that had a foot or more of snow in the DC metropolitan area, and you can see that we've at least had 4.5 inches of snow. So anyway, for what it's worth, could Climo help us out here? I don't know. Every system's unique, but hey, if you're a snow crow, you got to find something, right? So this is we go back to how significant this event is going to be, and this is for the Mid-Atlantic region. This is from the 0Z run of the GEFS, and what this shows is the 6, 12, 24, and 72-hour QPF versus the global forecast system reanalysis climatology. And if you look here, you'll see starting Friday evening, the 6, 12, and 24-hour QPF, and even the 40-hour QPF and some 72-hour QPF, the QPF that's being generated in the GEFS in the Mid-Atlantic region is it's an all-time record QPF value being forecast for this time of year, give it about 10 days either side of today. So the GEFS is forecasting a record QPF event, and it's going to fall snow. So I think the screaming message is this is going to be a record event, QPF-wise. somewhere in the Mid-Atlantic region. We could go look at some of these images if you want to, but here's the link to the site. So, and here's just the SREF plume for State College. And you can see the SREF has a lot of members that have very low snow. There's actually the minimum snowfall for State College in the SREF is 0. And the maximum snow is 3.18, although it kind of got some mix, but that's a lot of snow. So 0 to 33 inches of snow is like within the realm of possibilities. It looks like there's a clustering around 2 feet of snow for us, and it looks really promising. It looks like the snow comes in tomorrow evening, and then it picks up in intensity, and it's a nice snowy day on Saturday. So if I was home, I'd take a walk to Otto's because it's only a mile, and who wouldn't want to walk or ski in a snowstorm to get a beer? So, and yeah, you have a question?
Well, maybe you want to answer after you hit this next slide.
So here's
you say it seems like you're dismissing the SREF in favor of the GEFS. So what's the basis for that, I guess? Well, I'm not saying which is right or wrong. I'm just saying a lot of computational resources and brain power goes into these ensemble systems, and it's kind of scary to think that
it's
we would
scary.
just dismiss an ensemble
26
runs.
Do you have the wind anomalies from the
They look like the GEF, and we can look at them.
So they're farther south.
No, they look like the GEFS.
But the GEFS wind anomaly was pointed south.
They look real. We'll take a look at it. The 9Z's in too. This is the 9Z. Now this is the 6C GEFS, and the 6C GEFS says like our snowfall. There are a lot of members that are zeroed out. There's only about 2 members in the GEFS that show us that it's going to snow in State College. And in fact, if you look at the GEFS, you're getting excited about the 27th. I mean, let's talk about the 27th. Of course, on Sunday and Saturday we were talking about the 23rd. So like you get the drill here. But if the GEFS and the SREF are in different atmospheres over central Pennsylvania. Now, if you look at DC, they're very similar. And the GEFS is more robust with the QPF than the SREF over the DC area. And I've noticed the SREF tends to underperform with big QPF events. So, for what it's worth, there's an issue here. There's a serious issue here.
And so why do we believe the GEFS is it historically better? I'm not being a pan. I'm curious.
I don't know the answer.
The SREF is just dismissed like this. Why are we running it?
Well, I don't think people have dismissed the SREF because in Louisville and in Pittsburgh, for example, and other places in the Midwest, they have winter storm watches out. And in areas where the GEFS says it's going to be a near miss and the SREF says it's going to be hit. So I don't think the SREF has been discarded. And I think if you blend the models, I think if you do a blend, it's a really good scientific question. Is the GEFS better at this point than the SREF, or is the SREF? Well, no, I'll tell you on Monday.
but if some offices are issuing advisories or watches based on they picked one ensemble suite as the winner, and another office has picked another suite. I don't know that people that design the suites intend them to be this way.
Yes. I don't know which one performs better. Just based on what I know about these systems, in my experience, I'm a little biased towards the GEFS than the SREF and the NAM. But you can tell by the by the map behind you there, by the watches that are out, they pulled the watches a little further north in Pennsylvania, probably because the SREF was so robust with the QPF. And I'm sure a lot of people are chomping at the bit, looking at the 12Z. It's probably rolling in as we speak, But it's a complex question. It's a very difficult it's a frustrating forecast question because we're looking at 0 to 33 inches of snow. If you believe this SREF, it clearly could snow at least a foot here. Will that happen? I can't tell you that.
I think the Europeans are being used as the
guide.
arbiter.
Yeah, the European is biasing, and since the GFS and the GEFS, I'll say GEFS, I guess, it makes it clearer, are tending towards the European, I think that's playing a role. NCEP also makes a super blend of about 52 models.
It's up to 62 now.
62, and so the SREF is probably pulling that mean. In fact, if you look at the probabilistic snow in this event, boy, I'm talking forever, aren't I? If you look at the probabilistic snow at this event, you'll notice a lot of times, because of some of the really wet members, you will see in like a 30% chance of an inch of liquid, right? And yet the ensemble mean 50% contour was well north of that. It was in there. So that's saying that the median was skewed towards the low members. There's a couple of really high members in here. So it's just a real forecast quandary, But it's a good learning experience. If you're a young forecaster starting out, it tells you you can't ever rely on one model, because we're stuck with the quandary of 2 ensemble forecast systems that differ. If you pick one system, you could lose big. So it shows you that, I guess, to not lose big, you probably have to, unless you have a priori knowledge, you have to consider a blend of these ensembles and be mindful that there could be heavy snow in central Pennsylvania if the SREF is actually as skillful as the GEFS, and I can't answer that question.
Well, if this thing has such strong synoptic scale forcing, you would expect that the GEFS should do pretty well.
You would. Maybe the SREF too, though.
So Rich, sort of a related question, kind of what Paul's asking. We've talked about 0 to 33, we've shown CLIMO, we've shown at least one model that the Weather Service runs operationally and has a lot, although other respective models don't. When I look at the forecast for State College from the National Weather Service, there's no warnings, there's no watches, there's no advisories, in fact, there's no accumulations. Now, if you're a geek and you dig into the probabilistic stuff, it says 5 inches median, 13 inches max. How are you communicating this uncertainty with, a 30-40% chance of a very significant snowfall? Less than half, but let's say 30 to 40% based on what the NWS is putting out. How do you communicate that? How are you communicating that to the public? Because I can't find it on sort of what the public would look at. It's not a watch, it's not a warning, it's not an advisory, it's not a special weather statement, it's nothing.
Yes, I know we've been briefing the emergency managers on this storm and talking about a lot of uncertainty on the northern edge of the storm, and I just lost $5 because I was told if I don't use that word, I get $5. I always use that word, the UN certainty word. So anyway, it's a real difficult thing to do. Like for winter storm watch, which this time scale would be in a watch, we need to at least 50% confidence. And if you take the 2 ensemble forecast systems, it's almost impossible to get 50% confidence that we're going to get 6 inches of snow here right now. So
The Weather Service system says 40%, but it also has this big fat tail.
what for heavy snow here?
Yeah, if
yes.
you look at the stuff that's on your...
Yeah, we have a probabilistic website now that shows the snow, and yeah,
It says 40% for those. So, but it's this fat tail. So are your criteria wrong? Because you either, okay, we're 10% below that, so we have nothing. We don't even have the paper close pavers. I mean, we're not going to solve it.
Yeah, the only product that well, I guess you could do that on social media to some degree too, but the AFT, the area forecast discussion, covers the uncertainty and covers some of those issues, I believe. I don't know, each forecast has its own nuances, but we don't really have a good way, I guess, of communicating it to the more general user that we're on the edge of a significant storm. I don't know how that's being conveyed effectively. It's an issue. It's a serious issue with the storm. I know to some of our more sophisticated users, this information is being conveyed like we're in like kind of a iterative process of briefing them on the potential of the storm. It's difficult. If it wasn't for the SREF, we probably wouldn't be having this discussion, but the SREF is a player on the field, and it creates issues for us. If you didn't see the SREF, you'd be real confident that it's probably not going to snow over here.
Yeah, I mean, for tornado watches, we routinely issue watches for only 2% of the tornado watch area ever is threatened by a storm, and probably 0.5% is ever in a warning. But for the winter weather products, yeah, it's like we try to have the watches overlap exactly where the warners are going to be. We don't. Frankly, I'd like to see the watches be bigger than the area that ultimately gets the warning, but it doesn't seem
yes,
to be the
there's 2 prevailing philosophies.
I know you're just the messenger. I'm just trying to understand.
No, I understand that because
You get to kill them later?
just use tar and feathers. I can clean that off. But it's an interesting, it's an important philosophical concept because we're threatened with a major event all the way up to central Pennsylvania, and we don't have a really good way to convey that. And if you lean on the side of uncertainty, you could see I can make Paul's argument that maybe since it could be an extreme event, even though it's under a 50% probability, the potential exists that you should be alerting people, then cancel it. I've always, over the years, because of I guess the cry wolf syndrome for 35 years of doing this, I've kind of leaned towards due to uncertainty, wait till put the watch out until you have more confidence in it. But then what product conveys that to the average user? And we don't have a good way to do that. I guess this storm represents a real quandary for us, I think, and for everybody. On the other side of the coin is there are people who posted real numbers for State College and most of Pennsylvania, all over the place. I saw numbers ranging from 8 inches of snow to about 15 inches of snow for State College, and I've seen numbers as high as 36 inches of snow on maps people posted since Sunday, Monday on Facebook and other social media avenues. People that make videos and stuff, and it's like kind of crazy what's happened here in the last, 5 days, I guess. But conveying the potential for a big storm here is an issue still. Hopefully, it'll get clearer as the predictability horizon shortens. So, yes.
Going back to December, this past December, Buffalo snowed it. Never been a month with such a large normal. Closest month to it is March 2012, 1 March. That couldn't even come close.
Yeah, it was a fun December, but we have this is the big forecast issue right now. So I guess, any more questions on the storm, or we move forward? Yes.
Great comment. We've got the stress, but the fluids are split pretty evenly between the two cores. The ARW core
Yes.
is trending high, and the NMM core is mainly low.
And there's two outliers, two extreme ARW outliers.
Yeah, and
Two extremes.
I don't know if that has anything to do with it. I'm just throwing that out there.
Yeah. And the $1 million question is, how do you know which one's right?
You don't.
So if you don't,
Well, I'll tell you Monday.
Is there anything that's happening in the atmosphere right now that can give us any clue to what maybe happened here 48 hours?
I don't know the answer to that question. Years ago, we put a lot of time and effort doing those kinds of things, but we learned along the way that if you make the atmosphere look like it really looks in a model, the model will not perform well. So I don't know the answer to the question. Do you have a theory on this?
Well, I don't have a theory, but I have one. Obviously, this is a storm that is one that is highly influenced by some sort of confluent flow in the mid-troposphere.
Yes.
Right? And ultimately, it's a storm of where does the confluence set up, and then after that, where does the mesoscale band get?
Yes.
Right? Those are the forecast models. Last night's disturbance, the one that created 7 tenths of an inch of snow again in DC. But it had a little bit more going for it. The winds along now are pretty strong in the northwest. That helped shove the influence, the initial influence part. So the northern branch now has to do a bit more work in terms of foothold in the northern branch. As I said at the beginning of the week, in storms like this, the southern branch has reduced, but the northern branch holds in storm. And I'm seeing the atmosphere suggesting that the northern branch is going to be oriented in a way that kicks this thing out of the storm. And that may be what the models, all of those models of LC are responding to. I don't know that to be the case, but it's my work here.
That would favor less snow threat.
Less snow dress at higher latitudes.
Higher latitudes.
But
A similar discussion we partook on the Albany map this morning about that briefly, before they got stuck on the. Anybody else? Yes.
I also want to point out that the STREP members that do have a significant amount of snow here push that snow line all the way up into like the Buffalo area of New York. And if you look at the number, those STREP members on that panel that the Penn State Wall has, you kind of see that this surge of moisture just going that far north, it kind of just doesn't make any sense. And I wonder why it's doing that. If it's seeing something with the vorticity max, those little filaments that just push too far north or something. I don't have an explanation for why, but I just want to point that out.
Anybody else?
Yes. How many times in the past has there been such a steep gradient in snowfall, like here in Baltimore?
Oh, all the time. I've been doing case studies for about 20 years, and I think I've titled about 15 of them "Life on the Edge." When you're on the northern edge, it's really tough. A lot of times, like, we're on the edge of the key. We could get climatologically, that's not often. Apparently, it hasn't happened yet. Yeah. It'll be interesting to see. We're going to add to the climate record. The climate record is going to be bigger. We're going to add more data to it. I'll move on and maybe we'll look at a few more things here. So this just shows this is the plume from 6Z showing the temperature trend over the next 8 days. You can see I'm on the 25th, we're supposed to approach a little above freezing, and then on the 27th that storm comes in. Potentially we go above freezing, and then we get a little bit chilly again. And then this is the climate forecast system forecast that starts on the 21st of January. This is the CFS and previous members. The red line shows the warmest CFS member over the last couple of days. The blue line shows the coldest. The black shows the ensemble mean. And you can see, unfortunately, when I grabbed this, I was navigating a point, but it actually shows a kind of a warm up early February where you can't see it here, but we get to about 30th degrees in the mean. And then it shows in late February, and it shows right now the CFS thinks maybe March will be a little bit chillier in February, but it looks like if you look at the CFS, this is for Williamsport, the CFS is showing we're really coming out here in the next 5 days of this cold episode, relative cold episode we're in. And it looks like we don't get cold again until like late. This is my eyesight's really good. Yeah, this is September, this is March. Yeah. So for what it's worth, it's the CFS show. Always fun to look at. So basically, it's going to remain cold here locally for the next 5 days or so. We can take a look at a few more things. But we should get some snow here. I think we have a good chance of 0 to 12 inches of snow. Probably comfortable with 0 to, I would say that 0 to 3 is probably a realistic forecast. The SREF is clearly an outlier, and we kind of talked about that. And, trace to 2 or 3 inches is probably more realistic. And there's a big snow going to occur to our south and east. We're going to probably be bridesmaids for this, but we will be bridesmaids for the really big stuff. And but there could be some sleet if you look at that event, which could limit the snow and it could limit the blizzard condition issues. But the real heavy historic storms are probably going to remain, well to our south and to our east. So if I switch gears, I've taken a lot of your time. So what is that? Had some stuff on maybe it's one of these. Oh, let's just see if by chance some of the 12Z. Aha. So here's the 12Z. Look at this stuff. Evolution of the surface pattern. This works. F11 on this or just F11? So we'll look at the cyclone evolution. This is the 12Z run. And it still shows the deep cyclone going up the coast. And it kind of leaves us. Right? We'll look at the 850 winds. They're always fun to look at. I did. So you can see, we start out, this is tomorrow afternoon, so -4 sigma 850 wind anomalies over the central Appalachian Mountains. We go to -5. -6, and then it kind of goes off the coast. It looks like it's southern New England goes off the coast. So it looks like about a 30-hour period, which is pretty strong winds. I guess if I had those kind of winds, you'd be worried about really strong winds, coastal erosion, and if you have powdery snow, at least anywhere the snow is powdery, doesn't have sleet probably blizzard conditions. So let's hope that some of the QPF is populated. We'll go for 24-hour. We'll go low because we're interested in staying out. We can probably go to a mid-Atlantic. We'll start with a full view here, I guess, because there's going to be potential snow in the Appalachians too. But it looks like the 1-inch contour just barely gets there. It's actually further south than the 6Z, I can tell you that. It looks like the 2-inch QPF contour is mainly south of the District of Columbia now. The snowfall totals could be plummeted. You believe this, right? I'll zoom into the mid-Atlantic region. It's funny how people get excited about storms like 3-4 days out, and the uncertainty continues. The details continue to fall out very slow. So here's the maximum extent of the inch contour. Just we're in the 10 to 20% range for an inch of snow. Pretty low. And if we look down in the DC area, the main 2-inch contour is down here. Is a little closed one. It's south of the district now. So the 2 to 3 feet snow threat may be diminishing if you believe the GEFS. They won't see the 15 feet spread. Let's go to like the probability. Let's see if it populated. Well, I talked a long time. The longer winded you are, the more things can happen on the environment. So it shows the 2-inch contour just stays south and west of the District of Columbia. So the heavy QPF in the District of Columbia is in the GEFS. That's 2 inches. But it says that the threat of really extreme heavy snow in southern Pennsylvania is diminished too. Let's go to 1 inch. Of course, we could go to the SREF and get a different answer.
You keep clicking for 48 more hours.
You guys got lunch coming in and dinner? So it looks like there's still a chance of double-digit snow at about the 50 to 60% chance in the lower Susquehanna Valley. So this is a really difficult storm. If you look at that, if we go to the SREF, 15Z of course hasn't run yet. Got to be 15Z for it to run apparently, or at least later. We'll go to the SREF pops, and we'll go. What's that?
You want the SREF now?
Yeah.
Do the 850 win.
850 wins. They're actually weaker than the GEFS, just a tad. It only gets to about 5 sigma. I don't see any. Oh, there's some sixes in there. Wow, there you go. It's over the same area, but not quite as strong a winds in the SREF as for the GEFS. It looks very similar. That's what's kind of odd about this, the QPF shield. Well, we'll look at the pops. We'll look at the 24-hour 1 inch. Come forward. So here's the interesting thing. We're at about a 30 to 50% chance of an inch, which tells you, and yet the mean, the mean 1 inch contour is way south. So there aren't a lot of members that are forecasting an inch of QPF for us. Nice 1.5 over the DC metropolitan. So it's way further north. This is, I guess if you made a blend of these two models, you'd probably come up with a more realistic approach. Let's just look at 24 halves. So the SREF says we have about a 50% chance of 0.5 inches of liquid. So that'd be a 6-inch snowstorm that would have verified. But it's got the much more significant QPF, at least the closed 1.5 contour over the DC area. Then there's precipitation type is the 0 degrees Celsius. So it's not an easy forecast, but it shows you that if you don't think probabilistically, you make deterministic forecast, you're going to get burned in this storm. Anybody else? Anything else? Yes.
So I saw something about the surface temperature being unusually warm for this time of year. How do you think that will affect snow versus sleet?
Well, it depends how strong the cold area stays in. The strong easterly flow would probably have a chance to affect some warmer air from the east area. And this has a real strong easterly flow. And I think that's why if you look at the precipitation type, you'll see like there's a lot of sleet issues. And I think if anywhere the coastal front pushes through, and that easterly flow, the coastal front's going to come pretty far west. Anybody who gets on the east side of the coastal front is going to change over the rain. And I think some of that warm air could be ingested. And I think that's one of the problems why there's so much sleet and freezing rain in Baltimore, Washington counties, which to me limits the threat of a blizzard a little bit in my mind, and it limits the snowfall from it. It's a player. It also helps the intensity of the storm probably too. Anybody else?
All right, well, we're going to go and wrap that up, so let's all thank Rich.
Next week's speaker is going to be Tyler Wood from
Well, you know what they're doing.